All right, so today we're going to look at section 3.3, which is called the factor theorem. And we did skip a couple sections in chapter 2 in the beginning of chapter 3. So remember, we're not necessarily going in order. So we didn't jump to section 3.3. Okay, so let's start with just a reminder of what it means for something to be a root. Okay, if something is a root or a zero, it means that you can plug it into the equation, and when you do, you get 0 as the answer. Okay, and we've talked about zeros and roots quite a bit. We've done second calc 0 on the calculator, so we've calculated them. So if I had something like 4x plus 2 equals, let's say, 10. What number could I plug in for x there? 2. And it would come out, actually, you know what, let me set it, yes, it would have been 2. I said 0, so let's set it equal to 0. How would we solve that if we wanted to get x by itself? Yep, subtract 2 from both sides. And then the last step, divide by 4. So x would be how much? Negative 1/2. Negative 1/2 is called the root or the 0 of that equation. If you plug that number in for x, you will get 0. That's what it means. Any question on that? And that one's easy enough. We can solve algebraically, but if we couldn't, we could graph this in y1, and then we could look at where it crosses the x-axis and do second calc 0, and we could get the same thing. Okay, so what we're going to look at is how we can use division to help us find roots. Because sometimes you might not have an equation that's as easy as that one. It's only 2 steps. And we've got to use division to help us. So let's say that I wanted you to factor the number 12. Okay? And factor means to write 12 as a product of something times something. And I tell you that 3 is a factor. Okay, so I'm giving you a hint. 3 is a factor of 12. How do you find the other factor if you don't know it?
Divide 12 by 3.
Right. You divide 12 by 3. So by me telling you 3 is a factor, that means 3 times something is going to give you 12. If you want to figure out what the something is, divide each side by 3, and you get 12 divided by 3 gives you 4. So 4 is the other factor. And now if you do 3, which is the factor I gave you, times 4, which is the one you figured out using division, you just broke the number 12 up into a product of 2 numbers. Okay? We're going to do exactly the same thing with polynomials. If I give you a polynomial, you don't know how to factor it, but I tell you something is a factor, like x plus 1. You can divide by x plus 1, just like we divided by 3, and figure out what the other factor is, as long as you know how to do the division. Okay? With numbers, it's more straightforward, but we're going to go through how to do it with letters, okay, with a polynomial. Now, notice here, we divided 12 by 3. What did we get for a remainder? If you think about it using like long division. Nothing, right? Anytime you divide by something that is a factor, you get a remainder of 0. And that's a handy fact that's going to help us. If you divide 2 things and you get a remainder of 0, then you know what you divided by is a factor. So if you take 12 and you divide by 5, you don't get a remainder of 0. You get a remainder of 2. Because you get a remainder of 2, that means 5 is not a factor of 12. Any questions on that? Okay, so why would we want to find factors of things? Well, I kind of told you earlier on that we're trying to figure out roots, numbers that you can plug into an equation and get an answer of 0. And factoring is going to help you do that. Let's say you had x squared plus, let's say, 5x plus 4. You might not be able to look at that quickly and solve for x, because it's a quadratic. But if I rewrite it as x plus 1, x plus 4, you should be able to look at it pretty quickly now and see what number you could plug in here to make that 0, and then what number you could plug in here to make that 0. -1, -4. Those are the two answers. Much easier to get those answers if you know how to factor it.
How did you get x plus 1 and x plus 4?
So if we check it by distributing, x times x is x squared.
Yeah.
And then x times 4 is 4x.
Oh, okay, I see.
X times 1 is 1x.
Yeah.
And 4 and 1 gives you your 5.
Okay.
Yep. But if this was a problem and you didn't know how to factor it, and I told you this was a factor, x plus 1, then you could divide this by x plus 1 and figure out that. Okay? Kind of like I said, if 3 is a factor of 12, you divide and you get the other one. It would take a long time to do it that way. Hopefully this is one you wouldn't have to do division, but you could. Okay, so we're going to use that same process that we just kind of thought through with the 12 and the 3 times 4, but with a polynomial. So what I'm going to do is I'm going to put the steps for how we're going to do the long division, and then at the same time, I'm going to do a problem on the right. So I'm going to do it side by side. Okay, so there's 5 steps that we're going to write down. So if you want to leave room in your notes or however you want to do that, there's going to be 5 steps here. Okay, the first step is purely just setting up your problem. Okay. If the dividend, just to be clear about that, dividend, divided. Okay, that's the names of the two. If the dividend is missing any terms, you have to fill in zeros for the ones you're missing. So we have to have every power from the highest exponent all the way down to the lowest. So we've got cubed, but are we missing any powers in the dividend?
Square.
We're missing the squared term. So we have to fill in a 0 as a placeholder for that. So we've got the cubed term. Now we've got the squared term, because we're going to need a column for things that are squared. We don't have one right now, so we just made room. We've got the linear term next to the first power, and we've got now the constant. Okay, so that's your first step. Fill in zeros for anything you're missing in the dividend. Okay, the second step, you're going to take the first term of the divisor, x, and you're going to divide that into the first term of the dividend. So you're dividing x into x cubed. That would look like that. So let's simplify that. What's x cubed divided by x to the first? If you divide x cubed by 1, you would get x cubed. But we're dividing by something that's not 1, so it's not going to be x cubed.
Subtract.
You subtract your exponents.
Squared.
That's x squared. Yep. And you're going to put that above your line that you made somewhere. Okay, so that's x cubed divided by x. Okay, next step. You're going to take the answer that you just got in step 2, that's x squared, and you're going to distribute it back out. like that. You're going to multiply it back out to each term in the divisor, and here is where you have to line up your like terms in columns. So let's start with x squared times x. That's x cubed. So put that in the x cubed column. And what's x squared times negative 3?
Negative 3x squared.
Put that in the x squared column. Okay, so that's step 3. Multiply that back out. Now, you're going to subtract the columns that you just created in the last step. So the way I do that is I go like this. Minus, put it all in parentheses because you're going to subtract the whole thing, and then draw a line. Okay, let's subtract them. What's x cubed minus x cubed? That's gone. What's 0x squared minus 3x squared?
3x squared.
3x squared. And now, we're going to keep repeating this process. I'm going to bring down the next term, negative 8x. And we have to keep going until one of two things happen. Either this exponent becomes smaller than that exponent. It's like we have an x to the first on the outside for the divisor. That hasn't happened yet. Or everything cancels out and we have a remainder of 0. Okay, in this case, everything has not canceled out. I still have stuff left here. And that number is still bigger than that number. So do the process again. Right, so now you go back to step 2. And that's the cycle that keeps repeating. So divide the first term of the divisor into the first term of the dividend. So now you're doing x squared, or, well, I'm sorry, I messed that. Let me fix that again. 3x squared. 3x squared divided by x. So now you're looking at your work you just did. We're going to keep working our way down. What's 3x squared divided by x? 3x. So you're going to put that there. And now distribute your answer back out. What's 3x times x?
3x squared.
3x squared. And 3x times negative 3. How about Ruben?
9x. Or no, -9.
Negative 9x. Okay. And now what do we do with those two columns? Subtract them. 3x squared minus 3x squared. You should always get something that cancels out. If you don't, you made a mistake. What's negative 8x minus negative 9x?
Negative 17x.
Careful, that would be negative 8 minus 9x. Just x. That's negative 8x plus 9x, which is 1x. Bring down your next term. Exponent here is a 1. Exponent here is a 1. You got to keep going until the one on the inside is smaller. So we got to do one more time. So take x and divide by x. 1. Okay, distribute that back out. 1 times x. 1 times negative 3. And subtract your columns. What's x minus x? 0. That's gone. What's 3 minus negative 3? 6. There you go. 6. So now, how would we write our answer? Okay. 2 ways. We can write it as quotient and remainder. Okay, the quotient is what you have on the top, x squared plus 3x plus 1. And the remainder is 6. So that's one way you can write your answer. Now, did I get a remainder of 0? No. So what do you think that means about x minus 3?
Not a factor.
Yeah, it's not a factor of x cubed minus 8x plus 3. So if you were trying to factor this cubic, x minus 3 is not what you should use. Yep.
How did you get positive 3x to the square if you minus 3x from 0?
Positive 3x, so 0 minus 3x. Yeah. Okay, so that's one way you can write your answer. Here's a different way. You can do it the same way you do it when you learn log division with numbers. If you were doing, let's say, 13 divided by 5. How many times does 5 go into 13? 2. And what's the remainder? 3. So one way you can write your answer is quotient plus remainder over the original denominator. Let's try that here. Quotient is 2. Remainder is 3. Original denominator was a 5. That's how you could write your answer to 13 divided by 5. It's 2 plus 3/5, or 2 and 3/5 as a mixed number. Quotient plus remainder over denominator. Do the same thing here. Quotient plus my remainder over my original denominator, x minus 3. So that's a different way to write your answer, but it means the same thing. Okay, you would want to be familiar with both. But that is this pattern right here. Quotient plus remainder over denominator. Okay. Any question on writing your answer either way? Okay. So let's try this one. Okay, first step, check for any missing terms in the dividend. Are there any missing terms here? No. They already filled in the zeros for what we were missing. Okay. So now, what's the first calculation that we're going to do? What divided by what?
2x to the 4th power divided by 2x squared.
Yep. 2x to the 4th divided by 2x squared. And what is that going to give me?
X squared.
X squared. Okay. What do we do with the x squared now? Jade, what do we do with that x squared?
Distribute it into your divisor.
Yep, I'm going to multiply it back out. So that's going to give me 2x to the 4th. It's going to give me x cubed. And then x squared times 1 is just x squared. Okay. Now we've got 3 columns. And what are we going to do with those columns? We're going to subtract them. 2x to the 4th minus 2x to the 4th is gone. What's negative x cubed minus x cubed?
Negative 60. Just cancel out.
Not unless it was negative x cubed plus x cubed. We have negative x cubed minus x cubed. Negative 2x cubed. And what's 0x squared minus x squared?
Negative 1x squared.
Negative 1x squared. And you can bring down the next term. It's just a placeholder. There's nothing there. 0x. Okay, so let's do our division again. What's the calculation that we're going to do off to the side this time?
Negative 2x cubed divided by 2x squared.
Yep. And what's that going to give me when I do that?
Negative x. Yeah, just negative x.
Just negative x, because when you divide these, you get negative 1. When you divide those, you get positive x. Negative 1 times positive x. Okay, negative x. Distribute it back out. Kim, what's negative x times 2x squared? Like that? Cubed? Yep. And Serenity, what about negative x times positive x? What is it? Negative. And negative. So we're multiplying an x times an x, which is going to give us something with an x.
X to the second.
Negative x to the second. And then negative x times positive 1 is negative x. Okay. What happens when we subtract there? What's negative 2x cubed minus negative 2x cubed?
They cancel out.
That cancels out. What's negative x squared minus negative x squared?
Negative 2x squared.
Cancel.
That cancels out,
Oh, yeah.
because that's negative x squared plus x squared. When two things cancel out in the same step, that's always nice, because that's going to eliminate having to do division an extra time. And what's 0x minus negative x? That would be x. 0 minus minus becomes a plus. Any question on that? Okay. And what do I do now?
Distribute.
Bring, nope, not distribute. We did that. Something else we got to do now. Yep.
You have to bring the term down.
Bring down the next term. And what happens at this point?
X divided by 2x squared.
No, that's your remainder because it's less than that.
Right. We can't do that because that has an exponent of 1 and that has an exponent of 2. So now we're done. So looked like it might have been a worse problem, but actually it was easier than the first one. So the quotient is what's at the top, x squared minus x. And remainder, x minus 2. Okay. Any question on that one?
Is there going to be questions on the test where you ask us to show the answer differently?
Like quotient plus remainder over divisor?
Yeah.
Yeah, it could be written that way.
Is it going to ask him like a weird name? Like, how is it going to ask for it?
It would probably say write your answer as quotient plus remainder over divisor.
Okay. All right. I
Yeah.
didn't know if there was like a term for it.
No, not really.
Okay.
The nice thing about writing it as, like if I do that in this one, quotient plus remainder over my divisor, 2x squared plus x plus 1. That gives me something I can check. If I type in the original problem on the calculator, okay, 2x to the, I didn't want to clear it, oh well. So 2x to the fourth minus x cubed. And you know what, I'm going to put this in parentheses. So I'm just going to insert a parenthesis. All right, so 2x to the fourth minus x cubed. I don't need plus 0 and plus 0. Just do minus 2. This is rough. All right, minus 2. And then we're going to divide by 2x squared plus x plus 1. That's the original problem. That's what they gave me. Now, below that, I'm going to put my answer. That, okay, what I just circled. X squared minus x. X squared minus x plus, we're going to need parentheses, x minus 2, close the numerator, open for the denominator, 2x squared plus x plus 1, close the denominator, close the entire term. Okay. If we did this right, then those two should look identical. This is the question. This was the answer I got. Let's do zoom 6 and see if they look exactly the same. Okay, so there's the original problem they gave me, and here's the answer that I got. They look exactly the same. So that doesn't prove anything, but it highly suggests that I did the problem the right way. Any questions on writing it that way? Okay. So let's take a look at what's called the remainder theorem. So there might be times where we're not interested in what the quotient is, and we're only interested in somehow getting the remainder really fast. Okay. Why would we be interested in just the remainder? Well, because we know that if you divide two things and get a remainder of 0, that is a quick way to figure out if something is a factor. So that's why you might just want the remainder. Well, instead of doing all this work just to get the remainder of 6, there's a much faster way we can do this if we only want the remainder. If you want this, the quotient, well then, yeah, you're going to do all this out. But if you only want the remainder, you can use this theorem. One thing about this theorem is that it only works in a very particular situation. You can have anything you want in the top, any polynomial, but the bottom has to be x minus a number, just like that. If the bottom is x minus a number, then the quick way to figure out the remainder is take the number that's in this box, not the minus sign, just the number that's in the box, and plug that number into your numerator. If you plug that number into the numerator, you will get the remainder. So I'm plugging that number into the formula, which I'm calling f, in the top. So let's try that on the first problem, because the first problem did fit this pattern. It was x minus a number in the bottom. Let's take the number after the minus sign, plug it into the top, and see if we get the remainder. Okay. What's the number that was after the minus sign for my divisor?
-3.
What is it? 3. That is the number after the minus sign. Don't include the minus sign. Right, so it's a 3. We're going to take that and we're going to fill it into, that's my numerator right there, if you were writing it out as a fraction. It'd be x cubed minus 8x plus 3 divided by x minus 3. All right, so let's fill in 3. What's 3 cubed?
Wait, oh, no, sorry. What was that?
27. What's filling in 3? What's 8 times 3? 24 plus 3. What's 27 minus 24? 3. And what's 3 plus 3? 6. And what did we get for a remainder when we did this problem? 6. Yeah, that will always happen. Okay, so that's a quick way to find a remainder. Take the number, not the minus sign. It's got to be the number after the minus sign. and fill it in for the letter. That would work on this problem. It would not work on this one. Because in this one, you're not dividing by x minus a number. You're dividing by something with x squared, and it's got other stuff. So if you want the remainder on this one, you got to do the whole problem out. Okay, so the remainder theorem is a nice shortcut, but the remainder theorem only works in this one situation. Okay, so here's two problems. They want us to divide f of x by h of x, write down the remainder, and then f of x by g of x, separate problem, and write down the remainder. Now they don't say they want the quotient, so there's no reason here to do the long division. You can, but it's going to take a lot longer. And if you're doing it on a test, you might run out of time if you're doing it the long way. So let's start with f of x divided by h of x and do the remainder. First of all, does the remainder theorem apply in this problem? Yeah, why? What is h of x? X minus 3. That's exactly what it has to be. It has to be x minus a number. Yeah. So
it wouldn't work for the g of x, right?
We'll talk about g of x in a second. It can work for g of x, but yeah. So x minus 3, that's perfect. What's the number after the minus sign? 3. You're going to fill that in to the top. Fill that into f of x. So 3 cubed minus, what's 3 squared? So 3 squared is 9 times 2. So minus 18 plus 3 minus 5. What's 27 minus 18? That's 9. What's 9 plus 3? 12. What's 12 minus 5? 7. We got a remainder of 7. Very quickly, that tells me something about h of x. What do we know about x minus 3? It's not a factor. If you were trying to factor f of x, you shouldn't be using x minus 3. It doesn't work. Okay, now let's do second one. F of x divided by g of x. First of all, does the remainder theorem apply on this one?
No.
Why not?
Because it's not x minus a number.
Could we rewrite it so that it is x minus a number?
Yeah, but once you have to flip all the signs for f of x, so how that would work.
No, we're just going to write this in an equivalent way. That won't affect anything that's in the numerator. If you rewrite the denominator, that as long as it means the same thing, like
-1.
yeah. So I can rewrite the denominator as x minus -1. Now the number after the minus sign is what? It's what's in that box. So fill -1 in for x, and that'll tell you your remainder. What's -1 cubed? -1. And what's -1 squared? 1 times 2. 2. So minus 2 plus -1, so that's -1, minus 5. Okay, what's -1 minus 2?
-2, or -3.
Minus 1?
-4.
Minus 5.
-9.
Let's see, minus 3, 4, -9. There's your remainder. So what do we know about g of x? G of x is not a factor. Nope. So what is a factor? Well, that's not what we're trying to figure out right now. But those two are not. Okay. So any question on using the remainder theorem? when you see directions in the homework that say use the factor theorem, we're using the remainder theorem. It's kind of the same thing. So use the remainder theorem to show that this is a factor of that. Okay. If something is a factor of something else, what do I hope happens? What do you mean 0?
Your remainder is 0.
It's what?
Your remainder is 0.
Right. When you divide this by that, you get a remainder of 0. So we don't have to do the long division. We just have to quickly figure out what the remainder would be. So does the remainder theorem apply to this problem?
Yes.
Yeah. What are we dividing by if we write it in that form? We're dividing by -2. So what number are we going to plug in for x? -2. Fill that number into what would be in the top. X cubed plus 5x squared, and so on. Right. So we've got -2 cubed, 5 times -2 squared. And when we do that out, we will get our remainder. Okay. What's -2 cubed? -8. What's -2 squared? 4, and then times 5, 20. What's 5 times -2? -10. All right, let's keep going. -8 plus 20 gives me
16. Or sorry,
12 minus 10 minus 2. What's 12 minus 10? 2. And what's 2 minus 2? 0. So I got a remainder of 0 when I divide by x plus 2. What does that mean about x plus 2? It's a factor. So now, if you were trying to factor that problem, which x cubed plus 5x squared plus 5x minus 2, that's how you would set it up if you want to factor it. You know one of the factors. One of them is x plus 2. How would you get the factor that goes there? How would you find the other one?
I know it, I just can't explain it.
Anyone explain how we get that other factor?
You just subtract 2.
No, you wouldn't do anything with subtraction to get that other factor. Yep.
You would use division to find the other factor.
And what would go here? The what?
Quotient.
The quotient, yeah. Just like if I said to you, I want you to factor the number 12. Right? I'm going to tell you 3 is a factor. How do you figure out the other factor? You divide 12 by 3 and you get 4. Well, if you divide this by that, whatever you get for the quotient, which we don't have a short way to do right now, we'd have to do that the long way, that would be the other factor, the quotient. What's that?
You said right now.
Right now, yes, there is a fast way to find the quotient in this problem called synthetic division, but it's not something we cover in this class. It would be section 3.4, but I don't think we do that one. I'll double check. We're definitely not doing it this week anyway, because tomorrow's a review day. All right, so last thing. Kind of summarize all the different things we've said about zeros and roots. So if you've got a problem like this, what number could you plug in for x that would make that true? -3. So we could say that -3 is a solution to that equation. When you set it equal to 0, -3 is a solution. that means that negative 3 is a what? What do we call the negative 3?
0.
A 0. What else do we call it?
X-intercept.
It's an x-intercept, yep. It's a what? A root, yep, all those things. So negative 3 is a 0. Negative 3 is a root. Negative 3 is an x-intercept. But here's one that's very important. X minus that number is a factor. If you know that a certain number is a root, x minus that number is a factor. How do they figure it out?
How does this come?
Yeah, I don't know how they figure it out. So let's look at this one. This one's important, that x minus something is a factor. So if I go back to the very first problem I gave you, I said to you right here the two roots were negative 1 and what was the other one? Negative 4. Those are the two roots. If I move this away, maybe it's easier to see it. X plus 1, x plus 4. So if I told you just that, and I said to you, I want you to work backwards from these two numbers and tell me what the factors would have been. You've got to think of two factors that you can fill that number into and that number into, and they come out to 0. Well, if you write down x plus 1, or you could think of it as x minus that number, that will work. If you plug in negative 1 there, you get 0. For the second one, the pattern is x minus the root. Here the root is negative 4. Okay. X minus minus 4, which would be x plus 4. If you fill in negative 4 for x right there, what do you get? 0. That means these are the two factors connected to those two roots. Because you can take that number, you can fill it into one of them, and the answer will come out to 0. So if you know these two roots, you can work backwards to figure out your two factors. And that's kind of the last thing we're gonna focus on. Okay, so let me keep that up. And what I'm giving you in this problem are some roots. Okay. I'm saying that these three numbers are the zeros of some equation. They're the roots of the equation. They're the x-intercepts of the equation. But what I want to do is figure out what is the equation they came from. So the first step is to figure out the factors they came from. Each one of these roots is going to come from its own factor. What could you put in your first set of parentheses? So if you filled in negative 2, you would get 0. X plus 2. What could you put in the second parentheses? So if you filled in a 1, you get 0.
X minus 1.
Yep. And the third?
X minus 3.
X minus 3. These are the three factors that have answers of negative 2, positive 1, and positive 3. Now multiply them together, and then you'll have the actual polynomial. So we're going to have to distribute twice. So we got x squared. What's minus x plus 2x? Yep, just x. And 2 times negative 1? Negative 2. Okay, so there's your first distributive. And now do it one more time. What's x times x squared? X cubed. x times x,
X squared.
x squared, x times negative 2,
Negative
2x, and now this one, negative 3 times x squared,
2x. Negative 3x squared.
and negative 3 times x,
Negative 3x.
and lastly, negative 3 times negative 2,
6.
positive 6. Combine your like terms, and that is going to be the answer. So it's x cubed, 1x squared minus 3x squared. That's negative 2x squared. What's negative 2x minus 3x?
Negative 5x.
Negative 5x plus 6. That's the formula that would cross the x-axis at negative 2, positive 1, and positive 3. And it's very easy to check. Type that in and graph it, and if it doesn't cross the x-axis at those three numbers, then something's wrong. Let's check it. X cubed minus 2x squared minus 5x plus 6. So remember, you're looking for negative 2, positive 1, positive 3. Make that a little bit bigger. Does it look like it crosses at those three numbers? Yep, perfect. So you can make it cross any numbers you want it to cross at by doing what we did right there. Okay. Any question on that? Okay, so the last one is this in reverse. Instead of starting with the roots and working our way down to the polynomial, I'm going to start with the polynomial, and we're going to work our way backwards and figure out the roots. Okay, so here's the polynomial. Now, in general, a cubic could be pretty hard to solve, so that means I have to give you a cubic where something nice happens. Okay, that it works out nice. And what's going to work out nice here is it's going to factor by what's called grouping. When you factor by grouping, you look at the first two, and then you look at the last two. And you pull what you can out of each one of them separate. Okay, looking at the first two terms, x cubed plus 2x squared. What do they both have in common that we could factor out?
X squared.
Yep, x squared. And if you factor out an x squared from x cubed, what would that leave you with?
X
Just x. You can check it by distributing it back out.
plus 2.
And then just a plus 2. Now the hope is we need to see this x plus 2 pop up again. If it doesn't, then we can't do factor by grouping. Okay, let's look at the last two. What can we factor out of those?
Negative 4.
Yep, negative 4. And what would you have to put here? So negative 4 times what you tell me is negative 4x.
X minus 2.
We need an x,
X plus 2.
and this would have to be a plus 2. Because negative 4 times positive 2 is negative 8. Yep. So what I said needed to happen did happen. We got 2x plus 2's. Now, what do that and that both have in common? X plus 2. So now you're going to take that out. X plus 2. If you take x plus 2 out of the first term, what's left there? X squared. And if you take the x plus 2 out of the second term, what's left there?
Negative 4.
Just the negative 4. Okay. So we're getting it. It's starting to get to this step right here. We're kind of at this step. We've got two sets of parentheses. One of them has a square, and then one of them doesn't. So now let's look at the one that's squared. X squared minus 4, that factors. Okay, it factors again. How can you write x squared minus 4 has two sets of parentheses. Yep.
It'd be x minus 2 and then x plus 2.
Yep. Because if you multiply that back out, you get x squared plus 2x minus 2x. That cancels. And negative 2 times 2 is negative 4. Okay. So now you've got 3 parentheses. You're at this step. Now you just have to work your way back to tell me the roots. What would you, and we don't have to write the same root twice. What would you plug in here to make that factor 0?
-2.
Negative 2. How about here? Positive 2. And here?
-2.
Negative 2. So what we have there, that's called a repeated root. Negative 2 happens twice. We don't have to write it twice. So we just say the roots are negative 2 and positive 2. You may get a repeated root, you may not. In this problem, there are no repeated roots. They're all distinct. In this problem, we had a repeat. Okay. Any question on that? Right. And then any question, I think we've done it before, about how to do second calc 0 on the calculator. Because you can always do that to find roots if you can't factor it like we did here. Any question on how to use the calculator to do that? So that's section 3.3. So those are the problems for tonight on page 171. So we are skipping quite a bit, but if you look at the lessons on Schoology, it'll be the next lesson. All the ones in between, I just didn't even put on. Reminder tomorrow, that's the review day. Make sure for Friday or even tomorrow, you do have your Chromebook because the review guide is it's going to be online.